Hello and welcome to ninth lecture in our comprehensive course on AI, ML and DS. Now here we want to talk about measures of variation. If you know previous mean, median, mode, harmonic mean, then uh, geometric mean, they were called measures of central tendency. But just like if this is the data set where the rough center points are there, it is important to estimate that. Similarly, with respect to those center points, how far the data is spread, that is also important to understand. So center points are estimated by measures of central tendency, but how far the spread of data is, that is understood by measures of variation. Now in these measures of variation, first is very simple, range. Range is the difference between smallest and the largest value in the given set of observations. A very, very simple definition. For example, you are given these observations and they are already arranged in ascending order. But suppose they are not arranged, then first you arrange them in ascending order. Then select the minimum value, select the maximum value and do maximum minus minimum. That will become the range. That your observations are spread over around 17 numbers roughly. Okay. Then percentile. Now, percentile, quartile, these are very important concepts and they will be repeatedly, once again and again and again required in this data science, machine learning, AI everywhere. Okay, so please pay attention. It's an important concept. So, percentile is a measure which indicates the value below which a given percentage of points in data set fall. So, what is the meaning? Things do not become very clear unless you see this next sentence. For example, pth percentile is that element in the data set. So one thing is clear that each percentile, when you attach some number, p can be any number, 10, 20, etc. So when you attach some number, you don't get some kind of range, some whole bunch of numbers. You get one pinpoint element. Please remember that. So the pth percentile is the element in the data set such that p% of the element in the data set are below it or having less value, and 100 minus p% because total it can be only 100%. So 100 minus p% of the element in the data set have value above that pth percentile element. What is meaning? Instead of p, you can put any number, say 50th percentile. So 50th percentile is that element such that 50% of the total observations are below that number, and 100 minus 50, that means also 50% of the observations are above that number. Now what is that? Can you recall something? Just now we have learned. Yes, it is median. So here somewhere we plotted one diagram, and here my median was. It was a 13-point data set. This was the data set, and here is my median. How many points are below it? Then 1, 2, 3, 4, 5, 6, and how many points are above the green line? Then 1, 2, 3, 4, 5, and 6. So 50% of the data points are below median, and 50% of the data points are above median. So median is also often called 50th percentile. Okay. Now you should speak this sentence for this sentence is important. This one you should speak this sentence for as many as possible. Say it is important, so I am even making it larger in font. As many numbers as possible for practice. Say 10th percentile is the element in the data set such that 10% of the elements in the data set are below that 10th percentile element, and 90% because 100 minus 10, so 90% of the element are above that 10th percentile element. Similarly, 30th percentile is that element in the data set such that 30% of the elements are below that particular element, and 100 minus 30, that is 70% of the element are above that particular value. Okay, fine. Now then this is one thing. Then quartiles. Now quartiles here is what? Then first quartile, there are three quartiles which are very popular for every data set. First quartile, second quartile, and third quartile. What is first quartile? It is that element so that below that element 25% of the smallest observations of the data set are present, or it divides roughly 25% of the smallest observation from the rest of the data set. For example, here this lower line, black bold line, or this extending up to a dotted arrow which is going at y2, that is called first quartile. So if my entire data is spread between minimum value here and the maximum value here, then first quartile is that element which separates the least 25% observation or the smallest 25 observation from rest of the 75% observation. Okay, so that is first quartile. Second quartile is 50th percentile actually, or median or whatever. It is that element such that it divides the entire whole data set which is between minimum and maximum value into two parts. 50% of the observations are below that second quartile line, and 50% of the observations are above that second quartile line. And then the third quartile is this particular third quartile, that is 75th percentile. Okay, 75th percentile. It divides roughly 25% of the largest element from rest of the data set. So here is my entire data set from maximum value to minimum value. This is my third quartile line. This is my third quartile line. So then this top 25% are separated from the rest of the data set, rest of the 75% data set, by this line which is going at y4. Okay, so that is third quartile. So very simple. First quartile means 25% are less than that value, which is at first quartile. Second quartile means 50% are less than that value. When I say less than, always remember less than or equal to. And third quartile means 75% are less than or equal to that value. Okay. So this is zero quartile because nothing is less than this value, and this is 100 quartile because everything is less than that value. Okay. So, but they are not important. Important are first quartile, 25% are less than or equal to that value. Second quartile, 50% are less than or equal to that value, and third quartile, 75% are less than or equal to that value. Now, why this concept is important? Because repeatedly in the data science, we will have to draw a plot which is called this kind of plot, box plot. What the box plot shows is the distribution of my data points. That this is my minimum value in my data point, this is the maximum value in my data point, and the box plot shows this particular thing. Okay, or here also box plot shows this first quartile, second quartile, and third quartile. These lines joining first quartile to minimum value or third quartile to maximum value, that is called whisker. This is called lower whisker, and this is called upper whisker. Similarly, here also this line where I am moving my cursor, this, that is lower whisker, and this is upper whisker. Now, why the concept of this whisker is important? Because it is for data science purpose. Normally, we focus on these observations more. That is the observation in the middle 50% of my data set, or that is we exclude the observation which are less than less than first quartile and greater than third quartile. However, please remember it is not that simple. It depends upon the application to application. If you are doing something like credit card detection, fraud detection, or if you are doing some medical application like heart attack prediction or cancer prediction, at that time the extreme values are more important. But by focusing on these middle values, at least we are ensuring that some consistent statistical distribution are obtained. Okay. Now, still, why only focus this much? Say, so what we do is, should I exclude all above third quartile and exclude all below, first quartile? Then no. Actually, we have decided that we will consider we will first define one term called interquartile distance. What is interquartile distance? That is the difference between third quartile point and first quartile point. Let me magnify this slightly. So third quartile point is y4 and first quartile point is y2. Then y4 minus y2, this is my IQR, interquartile range. Then to find those elements which are considered outliers, okay, you have to take this formula, that first quartile minus 1.5 times interquartile range. Okay, 1.5 times, this is interquartile range, clearly shown in this diagram that this is interquartile range. So whatever is the value at first quartile, okay, minus 1.5 times this length, interquartile range. That much region you consider significant. But beyond that, if you do, then that are called outliers. And similarly, here third quartile plus 1.5 times interquartile range, and the region beyond them, they are called outliers. So please remember this, because outliers and removing outliers and handling outliers, that will be required. Let us try to do the same thing by code. Okay. So this is for mean, median, mode, but okay, that much we have already done. But now we are also doing quartile. So fine. Suppose I have these data points 1, 2, 3, 4 up to 16 data points, and I am creating a NumPy array out of it. Now I am finding mean. Mean can be found by NumPy, so np.mean. Then median also can be found by NumPy, np.median. Harmonic mean, we saw that it cannot be found by NumPy. So either you have to import SciPy, as we had done in one earlier lecture, and then use hmean. And geometric mean, for that you have to use gmean. Or here you are doing the definition of harmonic mean, that it is the total number of observations in the data divided by the sum of 1 upon x1 plus 1 upon x2 plus 1 upon x3 up to sum of the reciprocals of various observations. Okay. So this is going by definition. If I insist that I want to do everything by NumPy only and I don't want to use SciPy at present. Similarly, for geometric mean also, we use this definition. Geometric mean is the simple arithmetic mean of log values of data. This is a slightly new definition. In previous thing, we had done it that way, that it is if it is two numbers, then two numbers product and then square root. If there are three numbers, then product of three number even n1, n2, n3, and then cube root. Then four numbers, then n1, n2, n3 up to or say k numbers, then n1, n2, n3 dot 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 up to nk and kth root. So actually our definition was somewhat like this. But remember, this and log both are actually one and the same thing, because whenever you have to handle exponential, if you take log on both sides, then that becomes easier. Okay, so taking logarithmic function is also in reciprocal of exponential function. And some who are not from mathematical background, they please pardon me. They just don't bother about how these are there. And if they are still worried, then import SciPy and just write one line of code that geometric mean value is equal to G mean. That's all. Okay, G mean of data. And similarly, they for these also they can just use one line of code that harmonic mean value is equal to H mean. But you should remember that unfortunately these two functions are not available in NumPy, so you have to import NumPy also for the rest of the calculation, these calculations, and for other these two you have to import SciPy. Okay, SCIPy. Fine. But these much we have already done. So let me do one thing, that I first delete that much portion and execute only this. So these are mean, median, and it is easy to know that mean is sum of all these divided by total number of observations. So here I am getting 8.5. Median is np dot median. So that is the middle value of observations. So that is also I am getting 8.5. Why? Clearly here even number of observations must be there. So let us say I remove 8 from this side, and not 8 but 7 from this side, and 7 from this side. So what remains then is 8 and 9 in the middle. So median would be the average value of that, 9 plus 8 divided by 2, 17 divided by 2. So that is 8.5. Remember, it is not necessary that mean and median are always equal, but here they are coming out to be equal. Fine. Now harmonic mean can be found by this H mean data, and geometric mean also can be found by G mean data. Okay, so let me even try to do by that method, because many people may not be comfortable. Yeah, this from scipy.states import G mean, H mean, and mode. So earlier I had shown, but once again. Okay, so okay, and now I comment this line, that is finding harmonic mean by definition, and make this line. Similarly, I comment this line geometric mean by definition, and make this line functional. And let us check first. At present, what are value? 4.7327 harmonic and 6.8. Now by SciPy the value may come out to be slightly different. Okay, so harmonic 4.732 and geometric 6.8. Now let us see. Hardly any difference. It is coming out to be exactly same. So let me keep this code rather than the previous one. Okay, because finding by definition may prove to be a little bit difficult for some people. So instead of that, Python has so rich set of libraries that practically anything you will find one or other suitable library. Okay, now here this matplotlib was also important, because I had that matplotlib in plot some more lines which I cut down. Okay, but let us now again put those lines and let us try to plot the plot. Okay, so let us resume. We had done up to mean plotting mean and median and harmonic mean and all that, but now same observation, same set of numbers from 1 to 16. Now how to find its quartiles? I told you what are quartiles. That first quartile means 25% observations are less than that. Second quartile is actually the median point. 50% observations are less than that. And the third quartile is the point 75, such that 75% observations are less than that. But will you every time find that point, that value manually? Then no, there is no need. This has already, NumPy has a function that is called np.percentile. And I can put any data and any percentile I can find. If I want my usual first, second, and third quartile, then I can put the usual values, 25% observations less than that, 50% observation less than that, and 75% observation less than that. So I will get my usual. Okay, and what is first argument to np.percentile? My data. Here what is my data? This observations, and these are the percentile values which I want to find. So this will, the right side will not give one answer, but it will give three answers. One, it will give Q1 first quartile, then it will give Q2 second quartile, and then it will give Q3 third quartile or median point. Okay, so it will give three values. But now if you want first let us find that, and of course interquartile range also, that is Q3 minus Q1. Here, this range I am talking about, Q3 minus Q1. So NP dot percentile is a very important function, because you will be required to find percentile again and again. So one must remember this function. It takes two arguments, the entire data and this percentile which you want to get. So, and we are plotting the box plot also. Actually matplotlib we imported just for plotting the box plot. Otherwise, if you just want to find values of the quartile and stop here, find Q1, Q2, Q3 and in IQR, interquartile range, then only NumPy is sufficient. But okay, so in this case, you can see these were mean, median, harmonic mean, geometric mean. But now this is first quartile, 4.75. So 4.75 is that value in my this data set, such that 25% of the observations are less than or equal to 4.75. And here it is this line. Clearly it is visible that it is between 4 and 5 and almost nearing 5, so slightly less than 5, so 4.75. Second quartile is 8.5, that is the median line, orange color line. So 50% of the observations are less than 8.5 here, and 50% of the observations are more than 8.5. And third quartile is 12.25, so 75% of the observations are, that is all this, they are less than 12.25, and 25% of the observation, these, they are more than that value, which is 12.25. Here you can clearly see that this upper black colored line, that is the third quartile. So first quartile, this orange is second quartile or median, and this is third quartile. Okay, fine. And interquartile range is always third minus first. So that you can easily find by doing this minus this, and that will come out to be 7.5. So the length of this region is, or this range is 7.5. Okay, and usually majority of the data points are spread in this region. Though there will be some data points here and there will be some data points here, but majority are spread here. And what will be outliers? Outliers are decided by those which are less than first quartile by 1.5 times interquartile range. So let me print what is the value of 1.5 times interquartile range also. Okay, so print 1.5 multiplied by IQR underscore value. Okay, and now that will also be printed. So 1.5 multiplied by IQR underscore value, that is this 11.25. So that means what are outliers for, not 11.25 maybe. Sorry, I did not put but Q1 minus and Q2 plus. Okay, so that I get my outliers. So now Q1 minus 1.5, this value is coming out to be minus 6.5. So that means though this data set is spread between 1 to 16, because this is just a sample, and we have seen that sample is just a part of population. So actually in a population there might be a point which is having minus 6.5 value. So that means that will be on the lower side, on this side, or there might be a point which is having more than 19.75 value. So as such my data set ends here 16, but that is just a sample. So there might be some value which is somewhere 19.75 or less than, between 16 and 19.75. So such values which are between 1 and minus 6.5 or between 16 and 19.75, those values are called respectively lower outliers and higher outliers. And these outliers are normally removed for usual applications, but as I said, it depends upon what you are doing. So if you are doing credit card fraud detection, cancer detection, then obviously the number of positive cancer cases would be very less, or number of fraudulent transactions would be very less. Total number of transactions are spread over these regions. Then actually maybe only out of 10,000 transactions or 1 lakh transactions, there would be just a few which are extremely low. Now extremely low you don't need to detect, because that fraud is not at all dangerous. But there are some transactions which are extremely high. For example, I am a user and I am using my bank credit card for 5 years, and throughout my entire history, all my observations have been $10,000. Minimum purchase has been $100 and the maximum purchase has been $500. So that my entire history of 5 years, that has decided my profile, that this fellow in a single transaction does from $100 to $500. Now, if suddenly a transaction of maybe $25,000 comes, then my credit card fraud detection algorithm must flag it. It must not ignore outlier. Okay, because their outliers are the point of interest. So what I'm saying is that these extreme points, they are outliers. You just qualify them as outliers, but whether to keep them in your further analysis for data science, data analysis, or whether to ignore them. That depends upon what you are doing. Okay, if you are doing cancer detection, credit card fraud detection, then please don't ignore them. They are important. Okay. Now then, this is variance and standard deviation. This we will take in next lecture. Thank you.